We good? Hey, how's it going, everyone? Welcome to Kotlin London, the kind of Pusher edition. My name's Alex, I work here at Pusher. I'm just here to do a few housekeeping notes before I pass you on to Enzo, who's the organizer. Before I do that, actually, just out of interest, who here has heard of Pusher before, just by show of hands? Oh, so like very few people, actually, so it's really great to have you here. If you haven't heard of Pusher, as most of you clearly haven't, and you want to learn a bit more, basically, we're a developer tools company. We spend most of our time and energy focusing and obsessing about building amazing developer experiences, as well as tools and APIs that help programmers like you and us focus on the problems that are important to our applications. Our main product is called Channels, and it's a real-time API. It helps you build real-time features into your applications. It's essentially a pub/sub API, which is like, it'll just scale infinitely with your application, basically. But what's really interesting, and the kind of things that are rotating on the screen, actually, is that over the last 2 years since I joined the company, we've been doing kind of like a lot of research and development. We obviously are quite embedded in developer communities. We talk to all our customers, and we're constantly kind of looking for patterns and trying to identify problems that programmers frequently face. And two things that we've noticed a lot over the last couple of years is developers building chat into their applications, as well as push notifications. And so two of our main products, the first one is called ChatKit, and it's essentially a library. It's got a Kotlin library you can install, and it gives you all the basic building blocks of building chat into your application. Things like typing indicators, read receipts, who's on line lists, all these kind of things. It makes it super easy to build chat into your app so you can focus on the things that are kind of unique to your application. Push notifications, very similar. It does what it says on the tin pretty much. It's a developer API for sending push notifications to both Android and iOS devices. I'm not going to talk about them very much, but the main reason I mention them is that all of our new SDKs for Android are built in Kotlin, which I think is pretty cool. So yeah, real quick, some housekeeping stuff. The kitchen is down there. Like, help yourself to pizza if you haven't already. Drinks from the fridge, alcoholic or non-alcoholic, it's all good. The bathroom's down there as well. The exit is pretty much the entrance where you came in, but the door is not intuitive. If you want to get out, there's a button on the left-hand side you can press. But the best thing to do if you're struggling is just to ask someone. We've seen people get a bit confused with the door, and it's not good. Also, by the door, there are some fire escape instructions, which I encourage you to read. But the long and short of it is, like, yeah, OK, like Kotlin's pretty hot, but it's very unlikely we'll have a fire. In that case, obviously, we leave the building. And we're meant to sort of assemble on the corner of Clifton Street, just around the corner to the left. But yeah, that's it from me. Let's introduce you to Enzo, who's going to introduce you to the meetup. Yeah, awesome. Thank you.
Right, I'll be very quick. Thank you for coming. Every meetup, there's more and more people. Very happy. Well, we have 2 talks, as usual. But before, just one thing. So if you want to be a speaker, if you never be a speaker before, you want to try, just came up to us, me, just tell us. We are very open as a community to getting new people, so be free. First speaker is Roberto. He's a recent Kotlin enthusiast, but he's really in love with Kotlin. So he's basically passing his nights studying, and is also now a contributor of the standard Kotlin library. So kind of. So big round of applause for Roberto.
Happy with that?
Yep. Hello, can you hear me? Yeah. I'll present. Let's make start a second. Yeah, I will present some work that I did on Kotlin. As Enzo said, I actually heard about Kotlin the first time 3 years ago, but I just started working real on Kotlin basically end of the last year. And so let's talk about the Go. I don't know how many of you have okay, so someone. And so this talk will be my, let's talk about how to do a computer program. And okay, these are some information if you want to know. And in a sense, well, let's talk about, Go became very famous because it was the last game where the computer was not able to beat a human. And it was predicted that it will take at least another 20 years for a computer to beat a human. But last year, Google, with the deep learning, managed. And this was quite big news. At the beginning, nobody. You may wonder why, since chess are basically computer are bit. Go is completely different. And this is the world champion, the Go. And this is how the Go more or less looks like in a play. A very quick introduction. Software, AlphaGo. And AlphaGo was using on Go, and then they apply also in several other games. And you can see Crazy Stone is the strongest commercial Go software. More or less in this area, a bit above 3,000 is the level of the champion. These numbers are more. And then Google did the first version that here, but not exceptional. And then he gained with the Lee, which was like number 3 or 4 of the world. And then he went for the top. And then on top of that, they did another version, AlphaGo 0, that was still stronger than the previous one. And it was also interesting because the old version of AlphaGo were basically learning the deep learning part on using all the human played before. But AlphaGo 0, we started from scratch. So basically, they train the net on itself. But we'll talk another bit about deep learning at the end of the talk. Now we'll go a bit more technical on the details and why Go is such a great game, and maybe I play Go. So it's a very quick introduction. Rules of the Go. I mean, comparing with any other white stones, and the other guy has the black stones. Each turn you put the stones on the board, and that's it. And when you have your stone completely surrounded by the other color stones, the stones go to remove. And okay, now you know all the rules of Go. Okay, there is another rule. You cannot you cannot play the same position that before. So you hit one stone, and then the other can hit back the stone and go back to the previous position. That is forbidden, so you cannot do that. But apart from that, I mean, these are 2 rules. There are no other rules. But the implications are incredible. And so this is the first, just to give you. So basically, if we have this position and someone put the black stone here, the black stone kill all the white stones. But if we have this position, you cannot put the white stone here because it will be automatically dead. And you cannot even put it here for the same reason. So any shape with they are called technically eye. Any shape with the 2 eyes is unkillable. two or more than two eyes. So it's alive, it's called. Any shape that has only one eye is killable. And sometimes those are called false eyes, like this one, because it seems like an eye, but if a white plays on C and B, then it can place on A and kill. It will kill these three, so this will be only one eye, and kill also the other one. So all the strategy of Go is to manage to have a group with two or more eyes. And this, but it's not actually a rule. It's something that emerges from the rules. And just for your reference, this, I mean, maybe you want to see it later, but a bit of program that do the Go part. The first one is a client, so it has no logic, but you can use it to play with other guys or play against an engine. Apache is the strongest open source game. Lila Zero is the new one, which is basically based on deep learning, but it's open source, so it's kind of redoing what Google did. And it's really nice. Like I think at the beginning of this year was still weaker than Apache, but probably it will be stronger in the future. And the Crazy Stone is a commercial program, is the strongest. And also Crazy Stone now is switching to deep learning. And we try to explain why. And instead, the new Go, it was the old program. So actually, there was something that I didn't tell you yet. In the Go, basically, program, there are the old generation, which is new Go, that is based on a set of rules, more or less like the chess player. Then all the others, like Apache or Crazy Stones, are using a strategy which is called Monte Carlo tree search. And we will see later some code about that. And then that was the current bleeding edge until Google came. And now there is also the deep learning strategy. But deep learning is something that goes on top of Monte Carlo tree search, so it's not that. Now there is this book in MERP from Manning that basically explain, is quite a nice book, how to do a kind of AlphaGo yourself. And when I see there was all this example in Python, and I thought, well, come on, Python, we can do better. We can do Kotlin. So what I did basically is taking the code of this book, translated in Kotlin. That was version 1, and then improving on the Kotlin part. And this is one, I think, quite interesting point. So left is Python, right is Kotlin, and it's almost identical. It's quite impressive. I mean, it's not some trivial code. The code is one of the most complicated piece of code. And it has a lot of if-else, and it's really, and I mean, so far I was considering Python the easiest and cleanest computer language. But I think Kotlin now is still better because it also has types, so it can really help you. With Python, sometimes it's really difficult to understand which type is expected or something like that. And just to give you an idea, this is the algorithm when you place a stone. So basically, well, first there are some guards that we are in the grid, and the point is actually free, because otherwise, of course, you cannot place a stone. Then basically, it creates some set that we wanted to know on the stone that we put, which are the stones of same color, on the opposite color, and the liberties. The liberties are basically the free place around. When you have a shape in Go, basically, each On the border, there could be another stones or it can be empty. The empty are called liberties. Because when you got no liberties, basically you died usually. So basically for each neighbor point, assuming, okay, this is a bit old version of code. Now it's a bit more, because this is when I did the conversion. Then if you look at the code in Git now, it's a bit more, not complicated, but it has a more optimization inside. Basically, it check the color and they put in one of the three set liberties, same color, opposite color. Then it create a Go string. Basically, I will look, but the Go string is a set of stones of Go that are on the same, basically they are touching each other. Not in diagonal, but directly. And then if the stone is touching other same color, stones of the same color, basically you have to merge the string. In one, or if you are putting a stone where three strings are almost touching, basically you have to merge three strings. And then once you do this, you have to remove the liberties to the other strings that are around, because now you are putting so that it's not a liberty anymore. And if some of the opposite color has no liberties left, that means that you completely surrounded a string, and you can put those stones away. So this is one of the most complicated piece of code, and it's really impressive. It's very linear, and it's Python and Kotlin are really, really similar. Okay, a bit of lesson learned so far. About the types, the question mark types, sometimes, at least for me at the beginning, also because I had some experience with Groovy, where using the question mark is not such a good idea. It was a bit scary to use the question mark in Kotlin. But then I completely changed the idea. I think a question mark is really, I mean, nullable types are really good things. So far, the types are really nullable. I mean, if there is a reason why the response can be null, I mean, a domain reason, that's completely fine. That's great. If there is no reason, the only reason that you put the question mark is because you have a lazy initialization, stuff like that, that's not good. But instead, the double exclamation mark is very bad. So I think there are no, or maybe very few in some case. Because every time you put a double exclamation mark, you are saying, OK, this type it can be nullable, but not here. And why not here? That means either there is some abstraction that is missing that you wanted to remove, or there is a kind of not so good coding, because actually it can be null in that point, and you can have problems. But we don't want to have a null pointer exception. So really, we should avoid the double question mark. Immutability is very nice. It's fantastic. But there are also some performance issues. So if you are in the very, very high performance code, maybe you wanted to verify, because sometimes it's helped the performance, sometimes it's not. So it's something we can maybe look at some code. Algebraic data types, which are the sealed class where you have several instances, are great things. And they can really help both performance and simplify the code. And the premature optimization is the root of evil. So you have to think, I mean, it's very good to optimize the algorithm, but before trying to optimize the code, you really have to measure. For example, at the beginning, I tried to put some inlines around, but inlines have absolutely zero impact on performance. Unless there are some specific, like lambda parameter and stuff where the inlines actually help you, or reified types. But otherwise, inlines have absolutely no impact on performance. OK, back. OK, maybe these slides were actually before. Anyway, these are the explanation how to capture. So if you are a Go, let's say, if you are in the if you are the black one, and you put a stone in where it's called A, you can hit the white. If you are white, I put the stone here, you can hit the black. So it's there is a lot of like a problem. And yeah, these are a bit of definition. Each one is a stone. A set of stones is called a string. And the liberties are the empty. So for example, this black block has 2 liberties. This was has a lot, so you don't even have to count. This has only 2. This has 2. And a lot of Go strategies based on the number of liberties. And then there is a group. For example, all the black stones here will do a group, which is very important when you study Go, I mean, as a human. But for the computer, there is no equivalent. It's very, very hard to define what is a group from the computer point of view, so we just avoid. We just talk about strings. And strings are touching, basically. Groups are connected, but not touching each other. Now, a strange problem with Go is when to decide who wins. Because, I mean, on chess, the last one wins. It's very easy. Instead, in Go, it's absolutely not easy to understand who wins. I mean, for human player, what do? Basically, they count the territory that you are surrounding. So, for example, if this was a play, the black one will have the A part, this 2 in the C, and also the stuff of those D white, they are actually dead. Because from this position, there is no way that white can save those stones. I don't know if, because basically, whatever white can do here, if a black put 1 here and then 1 here, die will kill 2, and then black put another, white kill, and then black kill all of them. Because it's not the 2 eyes. Instead, these are 2 eyes, and this is alive. But when you have a player, human player, basically they can decide this is live, this is not alive. If there is some difference of opinion, you can keep playing until it's clear. But it's very, very hard to do an algorithm to be able to do this. So what the computer does is keep playing over and over again. I mean, keep playing until all the left plays are only one side. I mean, one single empty space. Because then it's easy, because you never play where you have an empty space of your stones. I mean, black cannot, if the X is black. Black will never play here. And the white cannot play here because it will be suicide. There is no way that. And so when there is no place that you can play, you just quit. Then computer can just calculate calculate just the number of stones and the point that are surrounded on each stones. So, but it's strange because, yeah, you have to keep playing much more than a human will do. And at this point, I think, yeah, let's see a bit of, or maybe we can, actually, okay. So the board that you said before is the, actually, let me show you. Okay, this is a Go client. So this is not my. Let me. No. I cannot use my. First. I wanted to basically to show you how a play between professional looks like. Right. Okay, this is an AlphaGo play. Yep. So I will do very quickly. And so AlphaGo is the black and the white is the human. And this is how a professional game goes on. And there is a lot of strategy involved. And basically the strategy based more or less on that it's much easier to surround the territory on the corners. So first they play the corners, and then they play the lateral area, and finally the center. But on the other side, if someone get, for example, here, black is taking basically the territory here, but the white is getting the territory on center. So there is always a bit of a take and give. Very, of course, I don't even pretend to understand exactly. I mean, there is a lot of, but it's very cool. At this point, I mean, for even for a human player that is not professional, it's very hard at this point to understand who is ahead. But in this point, the world champion basically resigned because it was irremediably behind. Maybe something that, for example, those 3 stones are actually dead because you can see that there is no way that they can form 2 eyes. So they are already counted as white. And this instead are alive because here white has enough space to do 2 eyes. So this is a lot of stuff that stronger player do automatically, not even think about. And this, for example, these stones are actually connected because these shapes, I mean, if a white play here, black play here, so you can connect. So there is a lot of stuff going on. And so, but this is the the full board. When you play with someone else, basically, you can. Okay. I don't know. Are you a bit interested on this stuff, or let's see the code? Just another bit. Basically, this is one of it's called Tesuji. So this kind of a strange combination. Basically, here the black stones seems completely alive because you think, okay, these are the white. The white have only 1 eye. The black are here, and they are not far from here. So white is in a bad situation. But actually, these stones can be. There is a sequence basically where white put the stones here, and then black basically wanted to eat this one. He cannot place here because otherwise white eat these 2, so black will place here. Then white extend. At this point, black cannot put here because otherwise it will be eaten. So black put here, and white put here, and put the trap. And then black doesn't realize that there is a trap, so eat the white. White play again, black eat again. And now white do this. At this point, these 3 are on peril, so black have to put here. And black does hit this one. And basically now, black is completely dead. Whatever it does, basically, white can play here, black can try here, and then black. It's completely black. This is how basically you develop your strategy. It's a lot, and the rules are so easy. But just for the beginners, basically, what you want is to play on something simpler. And you play on the full board is 19 by 19. Instead, you play with the small one, 9 by 9. It's easier, and the matches are much shorter. So just to show you, basically, this is my software. So this is regulated one move for 10 seconds. So basically, one black here, the white will be the software. And with one move for 10 seconds, I can more or less beat it quite regularly. But with the one move of 20, 30 seconds, it beat me. So it's kind of, I wrote a program that is stronger than me. That's already. And so basically, this is more or less what it will look like. It's not a great move, but it's not completely random. It's and if I give him like 30 seconds per move, the move started to be quite good. And OK, we don't have time, but it's quite easy. And so OK, I wanted to show you this one. I have a bit of a problem. OK, so this was also quite interesting. No, actually, sorry. It's better if I explain you first. OK, let's do the how algorithm to play games works. The easiest is the minimax. So it's basically take the current situation, you do some evaluation, who is ahead. Well, not at the beginning. At the beginning, there is no evaluation. So it take all the possible moves, and then it take the possible move of all possible moves. So it create a tree of all the moves. Then at the end, it evaluate the moves, and then it choose according to the to who is the player. So here we'll take the lowest one, because of course it's your opponent, so we'll choose the best for him. And then you took the highest of the possibility of this level, and then you took the lowest. So each level you took either the highest or the lowest score. And at the end you have, because you assume that your opponent is playing the best for himself, and you're the best for yourself. And this is the first possible algorithm. And there is a problem that you have to expand all the moves, and in Go you have, but even in chess there are too many moves. So a possible, I mean, a better solution is trying to look at the moves, at the better moves first, and if you already have a move that is better, you basically prune the tree that is. So basically, if you already establish that there is a move where it can kill you, it's pointless to look at all the possible response, because you already know that he has a better move than this. So in this way, you can cut a lot of moves in the evaluation. But this is still not enough for Go. And basically, the Go program uses this Monte Carlo tree search algorithm. Because the problem with Go is that at some point, you wanted to evaluate. And for example, in chess or in other games, it's quite easy to evaluate. I mean, you have some heuristics. So you can count the number of pieces and stuff like that. But in Go, it's absolutely not easy, especially, I mean, not even professional can say at the beginning who is ahead. So what the program is doing some a rollout, so a completely random game. So it just put in a piece in a random place, only legal moves, of course. And the idea is that from a given configuration, playing random, statistically, the best position will win. I mean, the player with the best position. So if you do 10 times, it doesn't really matter. But if you do 10,000 or 100 times rollout, you understand who is actually winning that position. So and this is how basically you select the mover, you try to select the mover more promising, and then you do evaluation. And then you have to balance between discovering new moves or getting better evaluation for the moves that are kind of winning. Because maybe they are just winning. It seems they win, but just because of statistical fluke. So you have to run and run again. And so when you write a software to play Go, the most important part is how fast you can evaluate this rollout. And this is on my laptop, so nothing particularly fancy. And the first line was basically when I just take the Python code and copy-paste it and translate it in Kotlin. It was let's just look at the first, or just the second, just one column. The first column is on the 9 by 9, the second column 19 by 19. In time in milliseconds to do a single rollout. And you have to think that you need at least 10,000 rollouts to make something work. And so the beginning was taking 10 milliseconds on the small board. So that will be like 100 seconds to have, I mean, more than 1 minute just to have a decent play. And then basically I keep improving, and the current, the last situation is basically 20 times faster, more or less, more than. And well, most of lesson learned on this performance stuff is that what is really important is the algorithm. So trying to avoid, for example, using immutable Go strings instead of mutable ones really help a lot of performance. Using a neighbor map, so instead of I just have a map with everything that can be pre-calculated. In this case, it was all the neighbors from each point. Instead of calculate every time you put in a map, so it really helps. To understand if a position is high, okay, I improve the algorithm. And this was quite, so for example, at the beginning, the random bot, so the one that do this random, was calculating all the possible moves, valid moves, and then just pick up one random. Instead, now basically it pick up random, then it check if it's valid, and if it's not valid, it pick up another random. But this is much faster than calculating all the valid and then pick up one random. And then, okay, instead of shuffle all the possible moves, just do the single swap and then do the random one by one, basically. Oh, if you can look at the code, everything is in Git. So the last one is also quite nice. Basically, sometimes we are using map, like a hash map, but we actually, for example, I had the map with player 1 and player 2. So there was a map with the key player 1 and some stuff, key player 2 and some other stuff. But actually using an array is much easier, faster. Because if the map is completely filled, because we completely put all the stuff and we know exactly where to go, using an array is much more network. And I mean, coming from a Java world, arrays are kind of bad, you know, because they are low level and we want map. But actually, also with Kotlin, it's much easier to use an array than with Java. And for example, one advantage is that if you go on an array, you don't have to put the double exclamation mark because array always return. Instead, the map always return a nullable. And this was also helping a lot. And I don't know, I can show you some code. Well, let's talk about the next step. So at the moment, the algorithm is pretty good. It's already able to connect with the client, so you can play with it with a kind of decent graphic. OK, there is something. The number that we saw was for a single core, for a single thread. Now I'm working on taking advantage of the full threaded. That is a bit difficult, but also Kotlin helps with coroutines and actor. It's really nice, the code. And once I finish this, basically the next step is using deep learning. And the point of deep learning in Go here is to basically when we do this Monte Carlo calculation, we have to trial the possible position. So in the middle and end game, that's quite good. But at the beginning, it's quite hopeless because you cannot really try truly all the possible 400 position at the beginning. And instead, what deep learning help you is doing a lot of analyzing a lot of games. It uses this kind of a convolution. So basically, it has a big net that takes all the possible, and then it's split in small grid, smaller grid. And at the end, basically, it gives you the full, basically, a list of output which has the same number of the possible position on the board, with the position, basically with the probability for each one. So it can tell you which, it's kind of intuition. Analyzing the shape is understand the most good shape can be this, this, and this. I mean, the position where I could maybe play. And so you have a small number of a position, which are interesting, and then you can feed those to the Monte Carlo research at the beginning. So Monte Carlo research got a lot of improvement from this, because it doesn't have to, I mean, it started with a very good approximation. And then, of course, to have the final number, you have actually to verify that it works. But it's an incredibly boost of performance. So this is, I think, after second half of this year, I will concentrate on this part of. Any question? Yeah, sorry, I did put my, well, it's on GitHub anyway, yeah.
Sorry, I saw that you were using coroutines. What could you tell us about your experience?
With the coroutines? Oh, okay, so my experience has been, I had no problem so far. They are very fast. So comparing with using Java fork join directly, I mean, I'm working on the backend, I'm not sure on Android, but I didn't notice any performance issue. The only thing is that there is not much documentation. I mean, basically, apart from the very, very hello world examples, there is only one page from the Kotlin guys that explain, and it's quite tough. So if you wanted to use the producer, the actors, try to use the channel. For example, to do this stuff, what I have to generate the moves, and then I have a number of workers that's more or less like the course of the computer that analyze. And I don't want to have too many. I mean, I can create 1,000 coroutines at the beginning with all the possible solutions, then let it run. But actually, it's quite confused. I mean, it's taking a lot of resource. I mean, not as much as I tried, but it still take. I also try with like 10 million coroutines. It works, but it's lower than. I mean, I have a 10 core, so I mean 10 core, 8 cores. So no, 4 cores with hypercore. So, but more than 8, basically, I don't have any advantage in performance. Actually, they go down. So I needed to create one coroutine with that give the position, basically, just put the position and put the position in a channel. You know that the channels are connecting coroutines or actors. And the channel has a fixed amount that is like 10. I can also maybe show. And so basically, when it's full, the channel is full, the coroutine that is producing move wait, because it cannot put anything else. On the other hand, I have like 8 or 10 coroutines that are pick up node to be examined by the channel, do all the calculation, and at the end update the result. And yeah, it works. It's fast. It's very nice code, but it took me a lot to figure out exactly how to connect the code. So actually, this is something that I wanted to blog about because it really took. There is not much, but yeah.
Thank you.
I hope.
You're ready for Zan and the much anticipated Kotlin service.
Yeah.
This one. If anyone asks you any questions during the Q&A.
I need to repeat them. Sure. Hello, everyone. My name is Zen. I work at Pusher as a developer evangelist, and today I would like to present you the state of Kotlin. Precisely, I'm going to present you the results of a survey that I've been running for the past 3 months that a bunch of you probably saw or even filled in. Actually, let's do a show of hands. Who filled in the State of Kotlin survey? About half. That's good. Thank you, everyone who contributed, who took their time to do it. So yeah, we'll be looking at where we are at the moment in the Kotlin ecosystem. And yeah, so I work at Pusher, which is where we're hosting you today. And Kotlin is used for all new Android SDK development here. That's in products such as ChatKit, push notifications, and feeds. I played quite a large part to put it in there. As the original Android enthusiast. So yeah, my background is Android development. I moved into SDK development, and currently I'm doing surveys.
Jokes aside, I love Kotlin. Kotlin is, I think it's a great language, and more developers I spoke to, they basically share the opinion that it makes us happy. I don't know why, but it does. So yeah, with this survey, I wanted to learn. I wanted us to learn about the Kotlin ecosystem because no one's ever done it. So we didn't really have a comprehensive view of what the ecosystem is. I also want to produce something that can be used to promote Kotlin as a language that can be used by the community. So something that you can take to your team and try to convince them that Kotlin is maybe the way to go if you're doing Android applications, if you're doing native applications, if you're doing any web stuff, anything. And yeah, give back to the community. My dear wish was that we get 1,000 responses to the survey. So yeah, start in December. Start putting the questions together with a lot of help from the community. I've gone through several iterations to kind of put the survey into the shape that was then released to the public. And mid-January to mid-March, it was live. It was running. We were doing some promotion to get more and more people involved. We even offered a prize, which was a trip to KotlinConf, the premier conference for Kotlin developers. This year is going to be in October in Amsterdam. And the prize was essentially trip to Amsterdam with flights, hotel, and ticket to the conference. And we did a prize draw at the end. Was completely random, and anyone who filled in the survey, left their email, and wasn't a Pusher employee or their close family member is pretty much eligible to win it. And it was won by a person called Nikola Cirilovic from Croatia. So if you're watching, Nikola, congratulations again. There was an applause. Awesome. So let's go on. So I was hoping for 1,000 responses. We got almost 3,000, which is scary and also super exciting. It's also 10% off State of JS, which is probably one of the biggest state of kind of surveys going out there. 33% of people who landed on the survey actually completed it, which my fellow marketeers also tell me it's quite a good ratio. And on average, they took 13 minutes and 14 seconds of their time to complete it. Doing some maths, it also means that people have spent 25 days filling the survey. So yeah, thank you so much. The categories we surveyed were how Kotlin is being used, how people learn Kotlin, what are some of the favorite features and how they are used, and also Kotlin Zeitgeist, which was an experiment I did to kind of grab more open-ended questions, open-ended answers to questions. And lastly, I checked about demographics. So yeah, without further ado, I would like to present you the state of Kotlin in early 2018. Let's look at the usage first. 58% of people currently use Kotlin on a project. It's quite remarkable. People who don't use it currently on a project, they've maybe used it for learning or playing around. That's like 17% of those. And 13% of surveyed people say they have no plans and they haven't used it so far. Among the rest, there are people who plan to start using it, or who used it in the past, or who had only evaluated Kotlin as a potential language to make their software in. People use Kotlin mostly in both work and personal projects, out of the people who use it on a project anyway. So that's 66% of people surveyed. Apart from that, they are about 18% each only doing work or side projects. Out of curiosity, how many of you are Android developers? That's about right. A lot of hands went up. Because according to the survey, 80% of people use Kotlin to build Android applications. It doesn't surprise me at all because it's very popular in Android. And the ecosystem has been stuck with quite an old version of Java for a very long time. So yeah, out of the work projects, and to be honest, this graph is pretty much the same for side projects. 80% use it for Android development, and about 31% each use it for also server-side or SDK development. There's a few others who use it for other type of things. And yeah, surprisingly, the side projects, they don't really differ. Like it's pretty much the same distribution here. Among other things, people use it for scripting, and obviously also experiments and just learning and playing around. And I was also surprised to see data science there. Several people have mentioned that they use Kotlin to do some data sciencey things, which is pretty cool. Next thing that I checked was what's the percentage of people who have kind of Kotlin as their projects only made in Kotlin. So, and compare that to like people who said they use it in side projects and people who use it in their work projects. And the distribution is as seen. So 55% have 100% Kotlin projects in their side projects. So they're like, if you're doing something on the side, they're probably smaller, more experimental things, and like a lot more people are more comfortable just having full-on Kotlin there, versus 25% for people who have it in their work projects, which is also quite a nice number. I guess Pusher is amongst those 25%. Yeah, so in work projects, you see 25, and then about 15 to 20% in other kind of distributions. So 75 to 100, 50% to 75, and so on. 1.4% people said that they only use Kotlin in test in their work projects. In their side projects, the distribution is quite different because you see that it's heavily skewed towards full-on Kotlin, or 75 to 100% Kotlin. In Android, I think the 25%-ish is probably XML for views. Yeah, and a lot less people use it for tests on Android, apparently. OK, other programming languages, because it's usually not the only programming language that you work with. No surprise here, Java is massive, because it's kind of the older cousin of Kotlin anyway. And so is Swift, which is the super similar, but not quite counterpart on iOS. JavaScript and Node are just big, so that's why they were quite often mentioned. And lastly, there was Python. I was quite surprised to see Python there so prevalent. I'm not sure whether it's related to the data science, or it's just people who do Django and Flask and other things, or even scripting. But yeah, these are the few most popular other programming languages for Kotlin developers. Another interesting feature of Kotlin is how close it is to Java and how easy it is to migrate Java code to Kotlin. So we looked at how many people decided to do this conversion. So 87% of people migrated some Java code to Kotlin. It also means that 13% of people didn't do that. Maybe they just started out writing Kotlin directly. Maybe they just created new classes in Kotlin. I don't know. And yeah, those people who had done the migration vast majority use the wizard to convert individual classes, 66%. 56% of people did the conversion manually, and 47 decided to convert only snippets. By that I mean Android Studio and IntelliJ allow you to, if you copy Java code, automatically convert that into Kotlin if you copy it into Kotlin file, which is pretty cool. There's also 10% of brave souls who decided it's a good idea to convert the entire project. And 20% of all of people who done the migration decided it was a bad idea. I imagine it went something like this. So yeah, I asked about the reasons. Dependencies were a big reason why the migration didn't go as planned. So was reflection. A couple of names popped up on Android. It's Dagger, it's Green DAO, it's Realm. There may be a bit some tricks involved to getting this migrated correctly. In the early days, it was also Spring, and we can't just look at technical reasons, because there's also the organizational reasons. There might be corporate policy at play that prevents you from just migrating to a completely new programming language. So yeah, these are quotes. If you see slides like these, it means that they are direct quotes that I've taken from open-ended questions. So someone was made to revert it due to organizational rules. Or another team took the code and they didn't want Kotlin. Sad. On a more technical side, migration triggered a number of changes in the Java code, especially when you have a bunch of statics and it kind of breaks your API. This is what can happen. It's also that the wizard migration does not provide idiomatic Kotlin, and it puts a lot of null assertions, which can be considered code smells, which means that you might want to rethink this and do some conversion manually as opposed to using the wizard. So yeah, that was usage of Kotlin. Moving on, I decided to look at how people decide to learn Kotlin, what they use, and when do they learn it. So what's interesting is that this is a pretty much hockey stick graph. It started in 2011 with very, very small amounts, so only 0.1% of people picked it up in 2011, and exploded in mid-2017 after Google I/O, when Google obviously announced that Kotlin is now officially supported language for Android applications. So 46% of all people surveyed said that they started using Kotlin after Google I/O. Another important spike was in 2015. I can only speculate, but there was also the time when Jake Wharton, a very famous Android developer, used to work at Square, now he's at Google, released a white paper, originally internally at Square and then publicized it. It was basically an evaluation of Kotlin as a programming language that Square can pick up. And it was released as a Google Doc, and it obviously exploded. There was also a bunch of talks starting in 2015, so that's probably what helped the explosion of Kotlin in popularity. So yeah, reasons why people started learning it. Google supported Kotlin officially on Android. It's definitely a big one. So is JetBrains. So big companies like that, big respectable companies, when people see it, that's kind of their idea to just kind of believe and trust those companies. Tooling is also important. Luckily, Kotlin has JetBrains behind them, which are, in my opinion, the best IDE makers in the world. So tooling is there. And then there's community. I already mentioned Jake Wharton, and there's also Christina Lee and Antonio Leyva and a lot of others who, especially in the Android space, helped to to popularize Kotlin. And on the JetBrains side, there is Hadi Hariri, Svetlana Isakova, and Andrei Breslov, and many others who also did the same thing. One person who answered the survey also said they were introduced to Kotlin by their friend Leo. So Leo, if you're watching, thank you. You're a good person. So yeah, among other quotes and reasons why people picked it up is the popularity of Kotlin in a short period of time. We've seen the hockey stick graph. It's really astonishing. Java was very verbose, and Kotlin is just love and happiness, I guess. I think that was like Java being Java was one of the biggest, most often repeated reasons why Kotlin is so popular. So, for instance, this one, it's like Java++, although I don't know what to think about this. So yeah, the resources that people use to learn. No surprise, kotlinlang.org, the official website, is almost 90% of people use this to learn Kotlin. And followed by different talks at conferences and resources like Kotlin Cones. The most prevalent community-supported projects are, I would say, Kotlin Weekly, which is a newsletter, which Pusher has been sponsoring for the last couple of months. And the Kotlin for Android developers. It's a book by Antonio Leyva. It's been around for a while. He published it on LeanPub, I think, at first, and then it's been quite popular. And then, yeah, different blogs, different courses. I would also like to pay attention to the Kotlin Academy, which is a publication on Medium. Currently, it's had 4.8% of respondents say they kind of picked it up they learned Kotlin from it, but I think given that they're producing so many great pieces of content, it's going to be a lot more prevalent in the following iterations. So yeah, developers who learn Kotlin come from different backgrounds, mostly Java and Android, unsurprisingly, but also front-end, back-end, desktop development, other mobile. They may come from Swift. Maybe Swift developers decided to, hey, they have a cool thing on Android as well. Let's pick this up. Yeah, 3.8% of people decided, hey, I'm just going to learn Kotlin from scratch, which is great. I want to see what this changes to in the following years. So yeah, this was where people come from, how people learn, and what people used to learn. But let's talk about the features, because it's got some pretty amazing features. Null safety is by far the most favored one. So 80% of people say they love null safety. This was a multiple choice question, so people could say they love all of them. I try to encourage them to pick only 3. Following null safety, you've got extension functions, Java interop, and data classes, which are favored by 60-something% of people. Then followed by higher order functions and type inference, about 40-ish something. And lastly, you've got the newer features like multi-platform support and coroutines, which have been introduced in the later versions of Kotlin at 20-something%. 24 to be precise. Among other favorite features, you've got the when keyword, you've got the reified keyword, and you've got sealed classes and lambdas that popped up often during the comments. There was also a blooper in the original iteration of the survey. I must have come from the screening of The Last Jedi and then writing the questions, because I confused higher order functions with first order functions. And if you follow Star Wars, first order are the baddies of the new trilogy. So yeah, a bit of a blooper. So yeah, if we look at the breakdown of different features of Kotlin, 77% said that they've used extension functions. Extensions are, you can easily add what would otherwise have to be static utility classes, static utility methods in Java to existing classes. They're used to reduce Android boilerplate. They're used to kind of replace utility classes, as I just mentioned. A lot of people mention conversions, so strings, object, things they get from APIs, they just can convert them, and DSLs. What people say about them, we felt like going overboard with them, now trying to find a happy medium. They're not the best thing, but because they can easily be abused and overused. The most important use case is Lambda parameters for DSL style builders. And for clean code, because they make the code more readable. Because you can just name different things on things like strings, integers, any given object. You can just call them different. On the other side, you have coroutines introduced more recently. And only 29% of people have used them. Mostly for threading and any I/O, UI-based operations, and also as a replacement for RxJava. RxJava is the reactive extensions for Java. It's the library that brings us observables and the reactive paradigm. But most people on Android mostly use it for simplified threading and scheduling things on different threads. So coroutines, because they're just that, are probably going to be taking a bit of limelight from Java, RxJava in that sense. There's also a bunch of people who said they come from the C# background and they've missed the async and await keywords, so they've used that. So yeah. Some people also say I've used it with Arrow because they use it for comprehensions. I've got Paco over there in the audience, who's one of the main contributors to Arrow. If you have any Arrow questions, please ask him. Someone said they stopped using coroutines because they are experimental. Fair enough, they actually are. And someone used them fully in production for a fintech solution. Any Monzo developers here? No. OK, they also provide a very funny API when used to wrap JS promises. I have no idea what this means. Another popular thing in Kotlin are the non-JVM features, being able to target other platforms, 26%, out of which 15% are excited about Kotlin native, so the native compilation target for Kotlin. There's going to be possibility for writing Kotlin to be executed on iOS and native as well. Kotlin JS with 11%, and lastly, multi-platform Kotlin with 7% of usage. Outside of features, I also asked about build tools. So what do people use to build Kotlin projects? No surprise here again. Android Studio is with 75% clearly in the lead, followed by IntelliJ at 65 and Gradle at 62. They're all used for Android development, so no surprise here. I was quite surprised and disappointed why Cobalt, the native Kotlin build system, is only used by 1.1% of people. Honestly, I haven't used it, so it shouldn't surprise me that much, but yeah. Other tools included Bazel and Griffin, and also Buck. Apparently there is support for Buck as well for Kotlin. 41% have used a DSL in Kotlin. Prevalent is Enco with 23%. Enco is the UI declaration library for Android. Actually, it's 24%. Kotlin Gradle, the ability to write Gradle plugins in Kotlin, is another one with about 17%. And lastly, you've got Kotlin x.html, the DOM manipulation DSL, with 5.6. Among the others, they're mostly homegrown DSLs, because 24% have actually developed a DSL themselves. What for? It's mostly used for, a lot of people have mentioned Jake Wharton's, again, Jake, this is getting boring. Jake Wharton's Testing Robots. It's a blog that he wrote about nicer testing on Android by writing a DSL. A lot of people write UI declarations and custom data structures, DSLs. But there's so many use cases, from banks to AI to all of that. So people have mentioned pretty much everything. I was really interested in this, actually. It's you've probably seen that a lot of libraries are replacing C's with K's. So there was category, which was spelled with a K. There is inject with a K again. So I asked, like, what do you think about this? Do you like it? Do you not? Most people are indifferent, but 32% of people say that it should be compulsory. And 10% of people say that KDE did it 2 decades ago. But not everyone is so enthused. The survey started with a button saying comments with a K, so someone didn't like it. Classic Dylan. So yeah, that's enough for features. Let's look at the zeitgeist, what people actually think about Kotlin. What do they miss? What do they like? 29% of people say they are missing things in Kotlin. Most dearly missed is the ternary operator, at least for the server itself. SAM for Kotlin classes is also a big one. And yeah, there's like a lot of people miss new things all the time. Syntax sugar. Someone missed link, so it must be all the C# developers out there. Apparently, I've heard there is actually an alternative to link in Kotlin, but I'm not aware of it. It's interesting because a lot of people who filled in the JetBrains survey called Kotlin Future Features, they asked for collection literals, and they weren't that often mentioned in my survey. So yeah, more things that are missed. So custom operations, support for Vue, a single multi-platform IDE. I think IntelliJ does it up to an extent. And there's also Swift's guard statement. So like all the iOS transplants would be missing the guard statements from Swift. 21% of people don't like certain features in Kotlin. They don't like companion objects because the way it does this kind of interacts or kind of counteracts statics in Java. Some people don't like it's all public by default, even though it's also quite immutable by default. Someone says it's not a dynamic language. Not sure what to think about this, but yeah. But yeah, what is the best ones though? What people like? They like the features. They like the null safety. They like the coroutines. They like the Java interoperability. They also like it's a modern programming language akin to Swift, TypeScript, and others. They like it's not a Java. They like it's fun, pun intended, because functions in Kotlin start with a fun, are declared with a fun. And platform independence was quite often mentioned. Obviously, it's also a very functional, friendly programming language, so that was quite frequently mentioned too. My favorite quotes about this was, "It can be read like a story." I think that's just nice. And another one, "I smile again when writing code." That's just poetic, isn't it? And "The language does not get in the way of getting a job done." It's pretty cool. And my favorite one actually is "Mortal Kombat, the programming language." I'm not sure whether that means the arcade version was better than the home console ones, but yeah, I'm honestly, if anyone has any ideas, I'd like to learn what that meant. So yeah, that's the Kotlin zeitgeist. And lastly, we've got the demographics. We learned that Kotliners live everywhere, on Earth that is. We haven't detected anyone coming in from outer space yet. Most of the surveyed people are employed or in being students, but there's also others like CEOs, startup founders, interns, all sorts. How long have people been working as developers? I think this is a pretty standard distribution, honestly. When we release the report, we're gonna compare this with the Stack Overflow one just to see how this all stacks against each other. Number of people in your organization has. There is a big spike with 10 to 50 people and quite a large spike with the freelance. But nothing scary. There is quite a uniform distribution across the other size of companies. So imagine the 10 to 50 people are like small agencies, startups that are quite eager to try out new things, quite flexible to move quickly. And how many developers are in the organizations? A big spike at 2 to 5 developers. It probably means Android teams working on Kotlin. That's my hunch, because that's kind of the size of an Android team. 3.7% of people have more than 50 Kotlin developers in their orgs. So Google, JetBrains, the likes. Sectors, no surprise here. Tech is leading the charge, and pretty uniform distribution unless you're working in government or insurance. So yeah, that was the demographics. And I would like to ask you, what do you think about the future of Kotlin and the future of state of Kotlin? If you have any questions that you would like to see asked in the future iterations, because there will be more, what would they be? Get in touch, please, and let me know, and we can make this a great experience and use this to kind of just grow the Kotlin community further. That was State of Kotlin, and I am Zan Marken. Thank you. I don't think there's any. There is?
I don't know how it's in Android community. In web-server development, Groovy was better Java for many, many years. And did you plan to include, or did you include migration from Groovy to Kotlin in your questionnaire?
OK, the question was how about Groovy, because in Android, Kotlin has been a better Java for a while, and in server-side and backend Java, Groovy was the better Java for a bunch of years. And whether I plan to include a migration from Groovy to the survey. I did not plan about it. Didn't plan to do it. It wasn't really on my radar, but maybe it could be something that we ask in the future.
From the survey, from the negative points, how many people were concerned about on the status about the compiler and the openness of JetBrains in general? Because they were supposed to come like the compiler plugins and all these ideas, but they have disappeared from the roadmap for a while.
Okay, the question was about the negative parts of the survey, negative thoughts about Kotlin, and how many people were concerned about the state of compilers and compiler plugins. I'm honestly not sure. There wasn't many that I've seen, but I imagine if we ask that question directly, some people might mention it, but I haven't seen any spikes.
13% filled out a survey on a language they had no interest in, right?
Yes.
To win a prize to go to a conference in a language they had no interest in.
So the question was 13% of people filled in the survey about a language that they had no interest in. Yes, that is correct. And I imagine the prize, the trip to Amsterdam, was part of the reason why 13% did that. I think we're done. Thank you very much.
Thanks very much for coming. See you in the next meetup, hopefully in 2 months. Still a place for one speaker. So again, if you're interested, I'm trying to reach